Alright, so this problem is a lot like your force of friction where you could hang your boots using a Newton meter or your shoes. So you do need the formula for a spring, which is negative K delta X. So if the spring stretches by 0.5 meters, that would go in this section. Alright, and we want to find the spring constant, so we don't know K. Do leave the negative in here. And we know the weight of the boots is going to be 8 newtons. So hopefully you can see this is a pretty basic algebra problem. Just divide by 0.5 meters on both sides. And you get 160 newtons per meter. Yes, I know there's a negative sign here, and don't worry about it. Technically, the spring is pulling up with 0.8, and this got pulled down, so this would be your negative sign that would cancel out. And so based on this, what's the mass of the boot? So now at this point, you would have to think, well, we found the weight, which is a force. It's the force of gravity. So what's the formula for force of gravity? F of g, this is B, is equal to mass times gravity. So we know that this is going to be 8. We don't know the mass, and gravity on Earth is 9.8 meters per second squared. This is in newtons. So again, pretty basic algebra as long as you know what to do. Divide 8 by 9.8 meters per second, or 10. I'll take 10. And this is equal to 0.82 kilograms. Alright, I'm going to cut into this, but I'll erase this later. So if Tim hangs his boot from the same Newton meter, and the meter now indicates a weight of 10 newtons, how much does the spring stretch? So it's the same as this one, except it doesn't tell us, but we now know what K is, so we can figure out how much it's stretched. So the force on it is, again, 10 newtons. The spring is pulling it up. How much has the spring stretched? And I noticed we didn't draw a free body diagram in case you weren't sure. I always would. I won't take off points if you don't and you can solve it, but if you're not sure why some things are happening, I would check it. So the force of gravity is Fg. This would be negative, but your spring force is actually positive because it's pulling against gravity, so this is going to be a positive number. So our 10 newtons pulling up, this is equal to the negative K. We know that this 160 Newton meters from the last problem is our K, and we're trying to find delta X. So again, it's algebra, but you need to know how to use it. Just can't cross out. And then you get negative 0.063, because I am rounding it, meters. So this is how far it has to stretch downward. This would be your answer for C. Clearing all of this, so pause it if you'd like to copy. As always, in case you haven't, try these first and then go over them with me, so always try them first. And if you didn't get it right, alright, go over, start again, try to redo it without any help. This is how you get practice and get better, because I cannot give you a tutorial on the test. Alright, so Traveler SF. So for these, definitely draw a free body diagram. Again, won't knock off points if you can somehow get the answer correct, but I would be a little skeptical how you got the answer. So free body diagram, a SF Traveler pulls his 300 Newton suitcase. So 300 Newton suitcase, it's not our mass, but that is the force of its gravity. So his suitcase is 300 newtons. And he's pulling with a constant velocity, so that means acceleration 0, the sum of my forces must equal 0. So that means everything has to cancel out. So to check it in a counter, and he's applying a force of 200 newtons at an angle of 40 degrees with the horizon. So this is my horizon. He's pulling 40 degrees up. This is his applied force, or his force of his pull, and it's equal to 200 newtons. And it says calculate the friction force and the coefficient of friction between the suitcase and the airport. So there is friction on it. We don't know how much. This is our goal. And there is another force. What other force is here? Yeah. It's not sinking, so there has to be some normal force. And you do need to know the normal force. So I would get your X and Y chart ready, and let's do this. So things in the X direction. We know force of friction, but we don't know what it is. And also, some part of our force of our push. So it'd be the force of our push, what part? It's adjacent, which means you're going to be doing cosine of our angle, which is 40. Alright, and then in the Y direction, we have Fn, we have Fg, which we do know to be 300, and we have the force of our push. We already used cosine, so they can let you know, definitely got to use sine. So now we need to write out some equations for these. So we know that all of this has to add up to 0, and all of this has to add up to 0, where these are negative. So we know that Fp cosine 40, which we can actually, we'll get a number for that, minus friction is equal to 0. And we know that the normal force, again, we know what these two things are, and we know that it has to equal 0, so we can set up, it would be 300 and negative 300, and add it to Fp sine 40, and Fn equals 0. And then we also know that f of f is just equal to mu times Fn, although we do not know the mu, but we can very easily find out what the friction force is. So in fact, let's do friction first. We know that F of P is 200 newtons times cosine 40. We move this F over to the other side, so it'll essentially be equal to the friction force. So plug that into your calculator. Cosine 40 times 200. If you plug this into your calculator, you would get 153 newtons is equal to the force of friction. So that answers your first question. This is 153 newtons. But we now need to figure out what would be the actual mu. To do that, we know this, we need to find this, which is what we would do over here. So you can now plug in, we have negative 300, Fp, so this would be 200 times sine of 40. Plug into your calculator, you get about, you would round to 129 newtons. So we know that negative 300 plus 129 plus Fn is equal to 0. So if we add this to 300, or to negative 300, we get 171 plus Fn, or negative 171 plus Fn equals 0, so we know that Fn has to be a positive 171. 171. So now we can solve, because we can plug everything into this. So it would be 153 newtons is equal to mu times 171. Divide by 171 on both sides, and you would get about 0.9 would be your mu. And this, of course, would be mu kinetic because the suitcase is moving. So this is your friction force. This is your mu kinetic. These would be your two answers that I look for. Alright, remember, I will be here Thursday at 7 o'clock if you'd like extra help. Otherwise, good luck on the test.